Today we will be covering our second day of 7.2. We are still dealing with rational exponents, but now we're going to look at those that only have numerical bases instead of variable bases. For number 1, we've got the cube root of 80. The cube root means we need groups of 3 in order to go to the outside. So we're going to break down 80, 4 and 20, 2 and 2, 4 and 5, 2 and 2. Again, we want groups of 3. We have a group of 3 2's with a 2 left over and a 5 left over. That means the 2 goes to the outside. We still have the cube root. Left over on the inside is a 2 and a 5. We multiply those to get 10. So this is 2 cube root of 10. For number 2, we've got the 6 root of 27. You, at this point, may have realized or memorized that 27 is 3 cubed. If not, we can go ahead and do our factor tree and break it down. And we see that we've got the 6th root of 3 cubed. We need 6 and we only have 3. So some of you may be thinking, okay, that's as far as we can go. We can't bring anything to the outside. But don't forget, anytime those numbers, that fraction is reducible, we're not all the way there. So I'm going to take it from radical form and I'm going to change it into fractional exponent form. And that is our numerator, the root is our denominator, so don't forget that is 3/6. Well, 3/6 reduces down to 1/2. So this is really going to be the square root of 3. So don't forget, even if you don't have enough groups for that root, you still may be able to reduce it down. Number 3, we have 64 raised to the 3/4. That 64 is in parentheses, so we're going to have that negative 3 times. That means we're going to have a negative answer. Again, the numerator is what you are raising it to. The denominator is the root that you are taking. Since we are raising it to the 3rd power, we are having a negative 3 times, leaving our answers negative. I always, from the very first step, look to see if my answer is going to be positive or negative, and that way I don't forget later on. So we rewrite 64. 64, again, you can break down your factor tree, or we know that 64 is just 2 to the 6th power, all raised to the 3/5. We multiply since we have a power raised to a power, and we get 2 raised to the 18/5. And this is why I said it's so important to look in the very first step if your answer is positive or negative. If you had left this in parentheses, you would have a negative to the 18th power. And we don't have 18 negatives. We had those 3 negatives. This would make the answer positive. So make sure that you look at the very beginning whether your answer is positive or negative. And we've got a negative to the outside. We've got the 5th root of 2 to the 18th, which means we need groups of 5 to go to the outside, and we have 18. We have 3 groups of 5, because 3 times 5 is 15. And then we have 3 left over on the inside. Negative 2 to the 3rd power, that's going to give us a negative 8, 5th root of 8 on the inside. Remember, you don't want to leave it as 2 cubed, you want to evaluate that and multiply it out. Number 4, we've got that base of negative 64. In parentheses, if the parentheses were not there, we would not be taking the negative as well as the 64. And we're raising it to the 2/5 power. That means that our answer is going to be positive. If it's raised to the even power, our answer is positive, because that means we have 2 negatives which cancel each other out. So I'm going to get rid of that negative right away so I don't forget. So that's 2 to the 6th raised to the 2/5. We've got a power to a power, so we multiply, giving us 12/5. We change that into radical form, the 5th root of 2 to the 12th. We need 5, we have 12. We can bring 2 groups to the outside. 2 groups of 5, we took out 10, which means we have 2 left. So that leaves us our answer as 4, the 5th root of 4. Alright, our last one that we have to simplify, we've got 9 to the 3/4 power. We know that we can rewrite 9 as 3 squared. So we've got 3 squared raised to the 3/4. We multiply 2 times 3/4, and we get 3 to the 6/4, which reduces down to 3/2. At this point, hopefully you are realizing the pattern that if your exponent is an improper fraction, so if the numerator is larger than the denominator, then in the end you're going to be able to bring something out. This is the square root of 3 cubed. We need 2, we have 3, which means we can bring 1 to the outside, and we have 1 left over on the inside. Again, if you look at all of the ones that we broke down, 18/5, the numerator is bigger. 12/5, the numerator is bigger. 3/2, the numerator is bigger. If the numerator is bigger, you're going to be able to bring things from the inside of the radicals to the outside. Alright, so let's apply some of our properties of exponents. We have the cube root of 2 times the cube root of 3. We have the same root. When we have the same root, we can go ahead and put them underneath the same. So that's the cube root of 8. Just multiply your 2 and your 4. Well, the cube root of 8, we can rewrite 8 as 2 cubed. We need 3, we have 3, so that's a perfect cube root, leaving us with 2, nothing left over on the inside. We look at number 2, we've got the 4th root of 81 and the square root of 81. We notice that we have the same base, not the same root, which means not the same exponent, but the same base. I'm going to rewrite those into fractional exponent form. If this is the 4th root of 81, that is 81 to the 1/4, and that is the square root, so that's 81 to the 1/2. Since we are multiplying like bases, we're going to add those exponents. 1/4 and 1/2 is going to give us 81 to the 3/4. We're not done yet though. We always look at our base and see if we can rewrite our base in simplest form. We know that 81 can be broken down to 9 and 9. Each 9 can be broken down to 3 and 3. 81 can be rewritten as 3 to the 4th power. So really, if you're not good at seeing it, go ahead and always do your factor tree and break it down. So we've got 4 times 3/4, which is 3 cubed, which just leaves our answer as 27. For number 3, we've got the same root, 3 and 3, so we're going to go ahead and put that underneath one radical. And you can either multiply out 18 times 15 and get a larger number, but we know that all we're going to do is break it down to see pairs in the end anyway, so I'm just going to leave it as 18 and 15. So that's 9 and 2, 3 and 3, 3 and 5. We've got the cube root, so we need groups of 3. So we've got one group of 3, a 2 left over, and a 5 left over. So that's 3 cube root of 10. Remember, anything that has that many that we need that gets to move the outside, anything left over stays on the inside. Just like with the variables, when we're dealing with number bases, we want to look to see something that they have in common, a same root or a same base. In this case, they have the same base of 7. So I'm going to rewrite it into fractional exponents. Square root of 7 is 7 to the 1/2. The 4th root is 7 to the 1/4. We are dividing bases, so I know that I'm going to subtract, but I'm going to play that who wins rule. 1/2 or 1/4. 1/2 is larger, which means the 7 is going to stay on the top of the fraction, which means we don't have a fraction anymore. 1/2 minus 1/4 leaves us with 1/4. We don't want to have our answers with fractions in the exponent, so we change that into radical form. So that's the 4th root of 7 as our answer in simplified radical form. Number 5, we see that both of our roots are 3's, which means I can put that underneath one radical, and I can check to see if my fraction reduces. 3 over 192, I type that in and it does reduce. That becomes 1 over 64. We know the cube root of 1 is just 1. The cube root of anything is just 1. 64 I know is 8 and 8, 4 and 2, 2 and 2, 2 and 2. Since we have the cube root, we need groups of 3. There's a group of 3. There's a group of 3. We can bring 2 groups of 2 to the outside. That becomes 1 over 2 times 2, 1/4 on the outside. Number 6, all of them have the 8th root, So again, I'm going to put them all under one big radical, 128 times 8 all over 4. When I multiply 128 times 8 divided by 4, it works out really nicely. I get 256. We break down 256. We have 4 and 64, 2 and 2, 4 and 16, 2 and 2, 4 and 4, 2 and 2, 2 and 2. Now we have the 8th root, so we're looking for groups of 8. We've got 1, 2, 3, 4, 5, 6, 7, 8. We have exactly 8 2's, which means we've got one group of 2's going to the outside, so our answer is just 2. Sometimes it works out really nicely like that, sometimes it doesn't. So let's move on to rationalizing the denominator with numerical bases. We've got the 5th root of 3/4. 3/4 cannot reduce, so I'm going to go ahead and divide that into a numerator and a denominator. And I can rewrite 4 as 2 squared. Again, you want to break down that base as far as you can go. The root 5 tells me that I need groups of 5 to go to the outside, and we can't have that radical on the bottom, so we want to get rid of the radical by making a perfect group of 5. We have 2, which means we need 3 more. So I'm going to multiply it by the 5th root of 2 cubed. If I do that to the bottom, I've got to do that to the top. So on top we've got 3 times 2 cubed is 8. 3 times 8 gives us the 5th root of 24 on top. We've created our perfect group of 5 2's, which allows us to have, one group of 2's going to the outside. Number 2, we've got 2 over the 6th root of 81. Now we have 181, we need 6. So you could multiply the top and bottom by 5 more 81's, but then you're going to have a really big number that you're going to have to end up reducing in the end. So we're going to rewrite 81. Remember, we always want to write it down to lowest terms. This is actually going to be the 6th root of 3 to the 4th power. I am missing 2, so I could multiply the top and bottom by 2 and then simplify later on, or I can recognize the fact that right now I have a 6 and a 4. Anytime those two numbers can reduce, the whole piece can be reduced. 6 over 4, or 4 over 6 is the way it would be written, would reduce down to 2/3. So it's really the cube root of 3 squared. So I need 3, I only have 2. I'm going to multiply the top and bottom by 1 more, and that gives me 2 cube root of 3 all over 3. Again, we're rationalizing. The whole point is to create that group of 3 so I no longer have a radical so that I can move it to the outside. On top, we've got 2. 2 is not inside of a radical, so it stays outside, multiplied by the cube root of 3. And last, number 5, we do have a square root of 5 on the bottom, but I also notice that they have the same base. So the first thing I'm going to do is see if I can fix this without having to go through the hassle of rationalizing. That's 5 to the 1/3 over 5 to the 1/2. We play the who wins. The bottom is bigger. 1/2 minus 1/3 is going to leave us with 5 to the 1/6. It did not work. So now I have 1 over the 6th root of 5. I have 1 5. I need 6. So I have to multiply the top and bottom by 5 more. So that gives me the 6th root of 5 to the 5th. And 5 to the 5th is 3,125 all over 5. Alright, let's go ahead and turn over to the next page. Alright, so now instead of having radicals, we're going to have our fractional exponents. Even though we start with fractional exponents, we still need to have our answers in radical form. We have same basis, which means we add the exponents. 3/4 plus 5/4 is 8/4, and 8/4 just reduces down to 2, so that's 3 squared, which is 9. Here I have this quantity raised to the third power. I don't have the same basis, I don't have the same exponent, so the only thing I can do is distribute that 3 in. That becomes 7 squared. 1/2 times 3 is 5 to the 3 halves. 7 squared is not a radical, that's just our number 49. This will be a radical, and if I notice I have an improper fraction, so I know that I'm going to end up having to reduce. That's the square root of 5 cubed. We need 2, we have 3, which means we can bring 1 5 to the outside, leaving us with 1 5 left over on the inside. 49 times 5 is 245 root 5. Number 3, again, this time we have the same exponent. So we could distribute in the way we did last time, or we could combine the 3 times 2 to the 1/4, giving us 6 to the 1/4, all raised to the third, 6 to the 3/4. Again, we could combine those because they had the same exponent. And that means that we've got the 4th root of 6 cubed. We need 4, we only have 3. We can't rewrite 6 as a different base, something squared or something cubed. 4/3 doesn't reduce, so that's as far as I can go. So I go ahead and evaluate 6 to the third power as 216. Number 4, lots of different ways we can do this. Again, we have the same exponent, so I can go ahead and combine the 2 times 3, all being raised to the 4th, and that is being raised to the negative 1/4. Power to a power we multiply. 2 times 3 gives us 6. 4 times the negative 1/4 is a negative 1. We can't have those negative exponents. We take the reciprocal. When we move it to the bottom, it becomes a positive 1 exponent, leaving us with our answers just 1/6. Number 5, each of our pieces has the 1/3 exponent. That's like the same root. That's like saying everything has the cube root. So I can go ahead and do 5 times 4 divided by 2, all raised to the 1/3. And I can only do that because it's the same exponential value. 5 times 4 is 20. 20 divided by 2 gives us 10 to the 1/3. We rewrite that in radical form. Nothing can be broken down, nothing can be reduced. Number 6, 5 over 5 to the 1/5. We play the who wins. Don't forget that this is a 1 on top. Top wins. 1 minus 1/5 gives us 5 to the 4/5. We change that into radical form. That's the 5th root of 5 to the 4th. 5 cannot be rewritten. 5/4, nothing can be reduced, nothing can be brought out. So that's the 5th root of 625. We're almost done. Stick in there for a little bit longer. For number 7, again, same exponential value there, so I can put 15 over 5, that whole thing raised to the 1/2, and all of that raised to the third. Well, 15 over 5, that's really just 3 to the 1/2 raised to the third. 1/2 times 3 is 3 to the 3 halves. We notice that we have an improper fraction with our numerator bigger, so we know that we're going to be able to reduce. That's the square root of 3 cubed. We need 2, we have 3. We can bring 1 to the outside with 1 left over on the inside. And last, for this section, we have a negative exponent, so we want to move it to the top. When we move it to the top, it becomes a positive 1/3. We're not going to necessarily go directly into radical form because I notice that I can rewrite 4. 4 is 2 squared raised to the 1/3. That's 2 to the 2/3. We go ahead and change that into radical form. That's the cube root of 2 squared. I need 3. I only have 2. Nothing else can break down. So that's the cube root of 4. So this time, if you would have gone from here to here right away, you would have been lucky and you would have had the right answer, but you've always got to check to see if you can reduce. In this case, we just so happened that we wouldn't have been able to. Alright, our last two problems, adding and subtracting. And remember, if you're going to add and subtract, it has to either have the same radical or the same exponent. Here we've got the eighth root of 2, the eighth root of 2. It's 5 plus, if there's no number out there that's that assumed 1, 5 plus 1 is 6 times the eighth root of 2. For number 2, we've got 3 to the 1/3 and 3 to the 1/3. This is making it a like term. 7 minus 9 is going to be a negative 2, 3 to the 1/3. Now remember, even though I give it to you with fractional exponents, you have to have your answer in simplified radical form. That negative 2 is a coefficient, so we don't do the reciprocal. 3 to the 1/3 is really the cube root of 3. Alright, that was a long one, but we are all done now.